In this video, we're going to see how we can work out the nth root of a complex number. Okay, so first of all, we're going to think about the graphical representation of a complex number. So here we have a red arrow that is representing the complex number z. And the formula for this is z equals r, open brackets, cos theta plus I sine theta, close brackets. Now, r is the magnitude of complex number z, and theta is the angle between the arrow representing z and the axis for the real number line. Okay, now this arrow that's representing z can also spin 360 degrees and then still be in the right position with the right magnitude. So we can also write z equals r cos 360 theta plus 360 plus I sine theta plus 360. And in fact, we can spin this round by 360 degrees and do a full turn as many times as we want, and we'll still have the same complex number z. So in fact, we can write z equals r, open brackets, cos theta plus 360k plus I sine theta plus 360k. And k is just the number of full turns that we've done around the 0, 0 axis. Okay, so now to think about obtaining the nth root of this complex number. So we just take the nth root of both sides and then simplify, and we get the nth root of z equals the nth root of r times by, all in brackets, cos theta over n plus 360k over n plus I sine theta over n plus 360k divided by n. Now, this then works for any value of n that's an integer, and to get the complete number of possible solutions, we need to go from k equals 0 to k equals n minus 1. So you might also see this written as k equals curly brackets 0, 1, all the way up to n minus 1. Okay, so let's see how we can use this for an example where we've just got a value of 1. So graphically we can see that it's a red arrow going from 0 to the value of 1 on the real number line. R equals 1 and theta equals 0 degrees because we're 0 degrees away from the real number line. So we can write this down as cos 0 plus I sine 0. But again, we can do a 360 degree rotation. So we can also write this as cos 0 plus 360 plus I sine 0 plus 360. And in fact, we can go any number of whole rotations around this, 360 degree rotations. And so we can write the number 1 as being cos 0 plus 360k plus I sine 0 plus 360k. And I'm keeping the zeros in here intentionally to sort of illustrate and make a point. Okay, so what about the nth root of 1? Well, we now know that in complex form, 1 equals cos 0 plus 360k plus I sine 0 plus 360k. So if we take the nth root of both sides, we can get to the point where we have nth root of 1 equals cos 0 over n plus 360k over n plus I sine 0 over n plus 360k over n. Again, where k is this integer from 0 to n minus 1. So let's just look at some examples then. Let's look at the square root. This is where n equals 2. If we put the value of k equals 0, we obtain a square root of 1 equaling cos 0 over 2 plus I sine 0 over 2. So we're just at this point. That's the first root that we have. When k equals 1, we obtain cos 0 over 2 plus 360 over 2 plus I sine 0 over 2 plus 360 over 2. And we're 180 degrees round from where the original point was. So the second root is minus 1. So we've got two roots here, positive 1, minus 1. So that makes sense for the square root of 1. What about the cube root of 1? Well, we can apply the same methodology, but this time n equals 3. For k equals 0, we obtain a value and that is just a value of 1 here. So that is one of the cube roots of 1. We could also set k equals 1 and we obtain another cube root. This one is again a magnitude of 1, but it's 120 degrees anti-clockwise round from the original root. And then when k equals 2, we go another 120 degrees round anti-clockwise and we get another root of another cube root of 1. Okay, so again I've left these zeros in divided by 3. Obviously you don't really need that, but I'm using it to illustrate a point at this stage. Okay, what about the fourth root of 1? Well, the first one will just be the value of 1, and then at 90 degrees we've got another root, and then we can keep going round and get the 4 roots for 1 at this stage. Fifth root of 1, the 5 values are there and it's represented graphically, and there's a 72 degree angle between each of these possible solutions. Finally, we've got the 6th root of 1 and all the values there, so I think by now you get the idea of how this progresses. So that's been a video about obtaining the nth root of a complex number, and then it's been illustrated with the number 1 in complex form to show all the possible roots when you take the nth root. So I hope you found that useful. Please remember to like, comment and subscribe, and thanks very much for watching.